For the last 2 years, we've treated artificial intelligence as a highly capable but dependent tool. It was software that required a prompt, a person to check the result, and a massive, energy-hungry data center to keep it running. One major constraint on that dependency was memory. Most models would lose the thread of a task if a document grew too long. Now, systems from Google and Meta utilize 10 million token context windows, allowing them to reference entire libraries of data without forgetting the original objective. AI is also moving on to hardware designed to mimic the human brain. These neuromorphic chips solve complex optimization problems using a fraction of the energy required by standard processors, operating with sub-millisecond latency. Software architecture has become equally efficient. Newer models generate results by activating only a small portion of their total parameters for every word produced. This allows complex tasks to run up to 6 times faster than they did on the previous generation of hardware. The combination of near-limitless memory and ultra-efficient hardware reduces the need for constant human supervision. The engine is now capable of maintaining complex, long-term workflows with minimal external input. This independence allows AI to function less like an assistant and more like a proactive coworker. Instead of waiting for a prompt, these systems execute full desktop workflows, managing reports, files, and business operations autonomously. The AI model Junior provides a clear look at the scale. It currently writes 80% of its company's code, manages nearly all communications, and independently initiates half of the company's sales calls. We are seeing the rise of agentic AI, where multiple specialized systems work as a team. They divide a single project into discrete tasks and pass data back and forth in a closed loop, managing long-term projects without a human in the middle. One entrepreneur tested this by letting an AI agent run his software business for 30 days. Untouched by human hands, the system closed a $12,000 annual contract and increased the company's monthly revenue by over $13,000. These AI-first organizations show that corporate productivity is no longer capped by human bandwidth. Businesses are now operating as lean, autonomous entities that scale without adding more people. This autonomy is also breaking mathematical records that stood for decades. DeepMind's AlphaEvolve found a way to multiply 4x4 matrices using only 48 scalar multiplications, a problem that had remained unsolved at that level of efficiency for years. These systems are applying the laws of physics to real-world data. Models like GraphCast now produce 10-day global weather forecasts in under a minute, calculating over 1,300 variables with a level of accuracy that matches or beats traditional numerical methods. In biology, AI is programming living cells to behave like computer logic. Researchers used deep learning to search thousands of RNA sequences, eventually creating cells that function like Boolean gates to switch gene expression on or off based on specific inputs. Generative platforms are applying the same logic to medicine. By simulating 15 million virtual molecules, researchers delivered a drug candidate for testing in just 18 months, cutting the usual development time by more than half. Mapping weather currents, programming cellular logic, and designing novel molecules represents a shift toward the automated discovery of physical laws, work that previously required years of manual experimentation. These software breakthroughs are now driving a massive transformation in the physical world. For this intelligence to function at scale, it requires a new kind of global infrastructure. The U.S. Department of Energy recently announced over $1 billion in funding for AI-focused supercomputers. These systems, like Lux and Discovery, are designed specifically to accelerate breakthroughs in fusion energy and national security. This physical presence extends into the commercial space. In Los Angeles Union Station, a fully autonomous smart store now serves 60,000 daily passengers, managing over 400 products 24 hours a day without on-site staff. The billion-dollar scale of these installations integrates autonomous software into the physical landscape of national security and daily commerce. A moment of wonder. The scale of this change is best seen in AlphaFold. The system mapped 200 million protein structures in a single year, a task that would have taken human scientists millions of years to complete experimentally. That data has already been used by 3 million researchers. Studies linked to these AI discoveries are twice as likely to be cited in new patents, accelerating the rate of global scientific output. The speed at which these systems solve equations and run businesses creates a new environment where human labor and AI execution are increasingly inseparable. The future is an active construction site, and the tools have become participants in the build.